Hey everybody, welcome back to PLC class. So today we have a new implementation in a PLC. This is for a parking garage that you work at. This is for the parking garage where you work. So what happens is when cars come into the parking garage, there is a sensor, and this sensor, every time it gets flipped, counts it up one time. Counts up on this car counter. And every time that a car leaves, the sensor flips and it counts down. And so the idea between this thing is that when it hits the preset, when it hits the maximum number of cars that can be in the lot, it will trigger this done bit and turn on the red light to show that we're at full capacity. But of course, your boss has come to you today and he wants you to make this a little bit more intelligent. A little bit more intelligent than what it is already, because this is kind of simplistic. And so he's written out some ideas about what he would like you to do, and now it's your job to implement them. So the first thing he wants is that he would like some more counters, or he would like some more lights to show the percentage of the occupancy of the parking garage. In addition to that, he still wants a red light to show that there is a full capacity once the cars have entered a full capacity. And he wants one more light. He wants a light that will show us if there's any errors, if some car doesn't get counted, or some car gets counted twice, or something like that. If we have this car lot, there's going to be errors sometimes. So he wants a light to show when there are errors. Errors being when it is over the occupancy number of 10 or under 0. Like if it's a negative. If it's a negative, there can't be a negative amount of cars. So he would like some error handling, because it's been a big problem in our car lot. But you think to yourself, we don't know how to do that, right? We can show a done when this accumulator hits the preset, right? We can change some stuff, like we did with this right here. We change this from a done and went 10, but how would we go about showing, multiple different levels? How would we show multiple different levels? Now you may be thinking something we could do is we could create more count up and count down timers and give them all different preset of values, and then have them all connect to a different counter. And we could have a counter. We could put counter 2 for a preset of like 3 to show one light, and then counter 2 to be like 6, and this one to be like 9, and then this one could be 10. But that would be a lot. That would be a lot of counters. And I mean, we address them to the same sensors or whatever, but that would be a lot. That would be a lot of counters. We are going to introduce some new instructions that will help us achieve that with a little bit less headache, using just a single count up, count down address. So what I have made here is I have made a testing environment for some of the new instructions that we're going to be looking at. And these all have kind of like the same idea to them. You will see that there will be multiple instructions, but they all do the same thing. They compare two values to each other. Those two values can be any word value, so they can be something like this counters ACC or pre. They could be something like this timers. Let's see. Open. They could be something like this timers pre or ACC. They could also be something we've just stored in the integers. We could store them somewhere in the integers. They could be one of these status bits. The status bits that are words, which there are some. Let's see if we can find. Like this one is a word. It could be any of these kind of words level addressing, and we're going to compare them to another value. Also, we'll find out that we can just put in any number that we want to. We don't have to actually make them an integer or anything else. We don't have to put them in the integer table. So, first off, let's find our compare instructions. Alright, and it's under the compare tab. Like most things, it's just what it is. Alright, let's start with these two. Come on. Equal and not equal. So think for a moment. What will the equal and not equal commands do? Well, it'll take one source, one integer or word that we have somewhere, and say, is this equal to the next one? is A equal to B? And if it is, I want you to do something. I want you to set this line to true. So this line will become true if these two things become equal. And this light will turn on because this line will be true. And the NEQ right here is a not equal. And it does the same thing but backwards. It says, if 1 is not equal to 1, do something else. Okay, so let's set one of these things up. Let's say that I want this accumulated value. I want it, if this equals 3, to turn this light on. Okay, so let's do that. Let's first type in this counter's accumulated value, which is C5.0, dot 0, and what is it accumulated? It's ACC, right? ACC. I don't need to address it or do anything like that, or describe it. So right here, I said I wanted it to be 3, right? Well, I could do an integer here. I could do an N7 integer situation if I wanted to. But for these instructions, I can actually just say whatever number I want it to be. And I want it to equal 3, so I'm just going to type in the letter, or the number 3. 3. So we'll test this one in a second. Let's do this one right now. We want this one to go off the same thing. The same thing. C5 dot 0 dot ACC. And we want it to turn on when it's anything other than 3, when it's not equal to 3. So we're going to type in 3 for this one as well. All right, let's verify our project. Okay, everything is set up. So once I have done my verification, it has inserted how many things have been used. So you notice up here, my accumulation is already 1 because I have already accumulated it one time before I started recording. And so it sees that our accumulation is 1. And down here it says 3. So let's turn this bad boy on and see what happens. Download. Program has errors. Oh, I have an extra line. Download. Yes. Run. Okay, change our processor to run mode. So before I even touch anything, notice that our not equal is saying that this number, this accumulated that I've set, because that's what I've addressed it to, is not equal to 3. And so this line is true, right? And if you look here, it says this one is not equal to 3 as well. So this is not true. It isn't equal yet, is what I should say. All right? So let's count up. Let's count up and see what happens. Toggle bit. Toggle bit. Look. So I have set my accumulated value to 3. And it right here has decided that 3 is equal to 3 and it is thus true, has become true. Right? The not equal sees that 3 is 3, so it's fine. So it is not true. Let's do this one more time and see what happens. And toggle. Well, this has gone off because 4 does not equal 3. So this has gone off. And this is saying the same thing. 4 does not equal 3, so it has become on. It is looking for a not equal. Okay. So let's say now that we wanted to check if something was over a certain value or under a certain value. Here's what we would use. We have, well, let's look at these. We have a less than, a greater than, a less than or equal, or greater than or equal. So let's put them all out. Okay, I have created a set of these comparison instructions, so we can go through them one at a time and look at them all. And I've created some more lights over here, which are not really lights, but outputs, to show us when these things are activated. And just to kind of like nail the point home that we can use anything, I am actually going to attach my source up here, let's say to my timer. I'm going to actually do my timer. I can't drag and drop, so I'm going to have to type it in. And I will cut this so you don't have to watch it all. Okay, I very quickly off screen inserted the values that I wanted into these sources, so you didn't have to watch me type them all. Okay, so you'll notice, just to drive the point home here, that this is the ACC of this timer right here. And of course, the source A's for all of these are the same ACC for this timer. And source B's, all the source B's are counters, the counter ACC, the accumulated value on this counter. Okay, so let's talk about what these instructions actually do. The GRT, which is the greater than instruction. If you guys remember from 5th grade, when something is greater than something else, we use this symbol right here. And what it is asking is if source A's value is greater than source B's value, right? But it's not equal to. If source A is 4, if this is 4, and this is 4, then that is not greater than B, is it? That is the same. That is equal to B, right? But the less than works the same way, except the opposite. It's saying, is source A less than source B, right? But that is not equal. If these are both 3, that will not be less than. A must be 2 or 1 or 0 or -1 to be less than B. Down here we have the less than or equal. So this one works just like the less than up here, except it can be equal to. If this is 4 and this is 4, well that's true. The less than or equal will change to true here because 4 is less than or equal to 4. And the greater than or equal works the same way. If it is greater or equal to a number, it will come true as well. Okay, let's test this thing out. Run, and let's see. Okay, let's turn this on for a second. And so I'm gonna count up my counter timer because right now it's just 1, and I think that's kind of boring. Let's put this at. Let's count up 2, 3. As you see, as I count up, these values increase because this is connected. Source B is connected on all these to the ACC of this count up instruction. Okay, let's run this timer. So I'm going to do it a couple times, and you can watch. So the first one, when it is greater than 3, this light will come on, right? So let's toggle it on and see what happens. 1, 2, 3, and light is on. So it didn't come on at 3. It came on at 4, right? Because this is greater than. All right, let's do the next one. Toggle bit, and toggle bit again. Let's watch this one. So this is less than 3 right now, and as soon as it's not as less than 3, it goes off. Okay, then let's check out what happens with these equal to's. So let's look at this less than or equal to. So as long as this is less than or equal to 3, it'll be on. So let's look at it one more time. So 1, 2, 3. 3 is equal to 3, so it's still on. And 0, right? Let's look at the last one. So this one will become equal when it's 3 or higher. So 3, and now it's above. As long as this keeps on being higher than 3 or equal to 3, this will be green. Alright, so these are the tools we have. And let's see if we can engineer a better solution to what our boss wants for our parking garage with these couple of things. Just these couple of things. Okay, so we are back now at our parking garage. And what our boss wanted to do is he wanted us to set up a couple more lights to show this at certain percentages of occupancy. And he also wanted to have us make an error light in case if the number of cars was over 10 or under 0, meaning -1 somehow. If there was an error, he wanted an error light. So I'm going to create some more lights, and we'll go back seeing if we can implement some logic to make this thing happen. Okay, so I've put some more lights into this. We have 3 new lights, L1 to L3, and they all represent a different portion of cars being in the lot. And you will notice that these exclude anything higher than them, right? This is not over 1. This is 1 to 3 cars, and 4 to 6 cars, and 7 to 9 cars in the lot. So first thing first, let's make some logic for this thing, for this line right here. We want to include 1 car, right? So let's go to greater than or equal to 1, right? So we want this to be greater than or equal to 1. So let's get this source A. I'm going to see if I can pull this. Sure can. And so let's say this is greater than or equal to, and let's say 1. Ooh, no. So if we're going to include one car, we need something that is greater than 1, but also equal to 1, right? So I'm going to use a greater than or equal to. And what value should I put in my source A, right? Well, it should be the ACC of this counter, right? ACC of this counter. Good. And source B, I could put an integer if I want to, but I'm literally just going to type in 1, because I can do that. I can do that on these. 1. Okay, so it needs to be 1, 2, 3, right? So this will be true if anything is equal to 1 or over, but I want it to turn off. I want it to be not true when something else happens. So when should I make it not true? Well, I want it to turn off when there are over 3 cars. When there are over 3 cars in the parking lot. So I would need to use a less than, right? I want this less than to be on until something happens. So I do not want it to be equal to 3, right? Because we want to include 3. So this needs to be a number higher than 3, like 4, for example. So let's take the same ACC here, and let's change this number to 4. So this will be true too when this is less than 4, but over or equal to 1. This light will be on. Alright, let's use the same idea. This is between 4 and 6, right? So let's do a greater than or equal to again. And we'll take the same ACC of this counter. And we want this one to be 4 to 6. So we will do 4. And we will do another less than. I'll take the same ACC. And we want this number to go up to 6. So we need to go one higher than that, right? So 7. Because we do not want to include 6. We want to be higher than 6. Okay, last one. Let's do a greater than or equal to. And let's set this one to 7. Well, first we have to copy this ACC. And let's set it to 7. And we want it to turn off. We want this to only show when it's 9. So we do not want it to show when it hits 10, right? So we use a less than again. And we will set this to 10. And copy our ACC over to here. So if we scroll down here, we see we have 2 more things that we need to do before we can turn this baby online. So first thing is we have the old full capacity red light right here. And will this work? Yeah, it absolutely will work. This is absolutely fine. This is 100% fine. That being said, we have some new tools in our department of things that we want to use. So let's use one. So let's delete this. And let's use our equal instruction. Equal. So we want this to be full capacity anytime this equals 10. Right? We don't want it to be anytime less, and so this is essentially the same as the done bit. Essentially. But not quite. You might see some interesting effects of doing it this way. Okay? And we have an error light, right? So the error light is there to tell us if, through some sort of magic, the number gets above 10 or below 0. A car disappears, whatever. Somebody trips a light, somebody gets in with the same sensor. Let's see if we can make it an error light too. So we want this number for this error to be less than 0, right? So let's do less than, and we'll take this ACC and we'll make this 0. And we want it to also turn on when it's greater than, but not including So anytime that this becomes greater or less than 1, or greater than 10 and less than 1, it'll turn the error light on. Okay, let's save this thing. Okay, so let's go online. Download. Yep, go online. Run. And let's see. Okay, so let's click these in a couple times. Toggle bit. So right now, none of the lights are showing, right? Because they shouldn't be. Let's put one car in. One car is in. Our 1 to 3 car in lot light is on. Cool. Let's keep on watching. And so we have 2 cars in the lot right now. And let's put our third one in. Still on. And our next light comes on, right? Our next light comes on. So it'll keep on. Toggle. Toggle. We go down and our third light is now on. Okay, let's keep on toggling. Toggle, toggle, toggle. Alright, toggle. Toggle. See what happens at 10. Okay, our final light comes on. Our final light comes on. Okay, let's toggle this on one more time and see if our error bit works, and it doesn't. You know what I did? I didn't put these in OR logic. I want either of these to turn on this light, right? So these need to be in OR logic, and they are currently in AND logic. So let's change that now. So now I'm looking at these are now in our OR logic with each other, and they should turn on this error light. Let's see what happens. Toggle this bit. Okay, our accumulation is now at 11. Our full capacity light should go off because I'm asking it to be exactly equal to 10. And hey, here we go. Our greater than sees that this is at 11, and we want anything that's greater than 10. So our error light is on. Let's actually change our accumulated to -1, see what happens. If it still works. Make it -2 for fun. -2. Yeah, we're still in the same situation. Our error light is now working, and all of our other lights are off. Just as we wanted. So there you have it. We have fixed our parking garage now so that it'll show the occupancy to the outside world. And we even have some error handling now in those pesky cases where cars disappear or crawl the windows or whatever it is where we lose a couple of cars. It happens all the time. And now we will also have a light that will show us that as well. So having these new instructions has opened up a large possibilities of things we can do logically now. We've opened up a huge amount of things that we can do logically. We can pair them with jump instructions. We can have them jump at certain times. Essentially, these compare instructions plus the math instructions plus the file instructions or program control instructions, are essentially the basis for computer science. And if you have all those things, you can do some pretty wild stuff.